Please open to page 257 in your student journal. In section 8.3, we are still going to be graphing our quadratic functions. Remember, quadratic means our highest exponent on the variable is a 2. But now we're going to switch gears from vertex form into what is known as standard form. Standard form of a quadratic function is different than vertex form. We cannot just look at standard form and pick out our vertex, axis of symmetry, and all of our transformations. So what we want to do is figure out how are we going to get our parabola, which is that U-shaped graph of our quadratic function, without being able to just look at the equation and pick out all that information. When you have standard form, you have an x squared term. Its coefficient is known as a, or the number in front of it is known as a. Then you have an x to the first power. Remember, we just don't write the 1 for the exponent. Its coefficient is known as b, or in other words, the number in front of it is just known as b. And then you have a c value. C is the constant, which means there's no variable with it. Constant means there's no variable. It's just a plain number. So notice how that form is different from, I'll just sketch out vertex form up here just as a reminder for us. Vertex form, we had a times the quantity x minus h squared plus k, and each of those variables indicated to us what transformation happened to our graph. Now looking at standard form, notice I can no longer pick out those transformations. It is a completely different form. So let's see how we can use standard form to make graphing just as easy as it was for us in vertex form. Just a couple of things for us. That a value can still tell us, just like it did in vertex form, whether we're going to have a reflection or not. Or in other words, will our graph open up or will it reflect and open down? The graph will open up when the a value is greater than 0, or in other words, when it's positive. So just like we had with vertex form, when our a value, which was the number in front of the squared term, when our a value was positive, our parabola opened up. Then when that a value was negative, we had a reflection, and our graph opened down. So that's one of the things that is still the same from vertex form to standard form. That a value, or in other words, the number in front of the squared term, when it's positive, causes our graph to open up. When it's negative, it causes our graph to reflect and open down. So that's one of the things that is the same for us from vertex form to standard form, which is kind of nice. The y-intercept. The y-intercept is where the graph crosses the y-axis, something that you're familiar with from slope-intercept form. If we graph a point on the y-axis, the x value is always 0. Well, if I put a 0 in for all of my x values, if we do that in our equation up here, if I put a 0 in for each of these x values, those terms will all cancel out, and I'm just left with c. So the y-intercept is always going to be 0 for the x, and then whatever our constant is, which is that number without a variable, will be our y value. So there's one easy point for us to find, will be the y-intercept. It's just whatever our constant is. Now finding the vertex. I know in vertex form it was really nice and easy. We could look and say our graph goes left or right so many, and our graph goes up or down so many. And that gave us our vertex. With standard form, it's a little different, but we do have this nice slick little formula that will let us find the x-coordinate of the vertex, which also means we can find the axis of symmetry. Remember, the x value at the vertex is the same as the value for the axis of symmetry. So that little formula deals with the coefficients of A and B in our standard form. So let's put these ideas into action. Let's go ahead and graph all these little things. I know for most of us, it's not really going to click until we get to see it in action. So let's go ahead and turn to page 259 in our student journals. And let's look at question 5. And let's do all of the pieces that we just talked about. So let's start off with, let's find our axis of symmetry. Let's start there. Our axis of symmetry. Now that little formula, we had negative b divided by 2a. And you might be thinking, Miss Golly, so what's the b and a deal again? The a value is the number in front of your x squared. The b value is the number in front of x. And then c, which isn't in that little formula, but we're going to go ahead and label it, c is your constant, number without a variable, just a plain number. So let's take these values of a and b and let's put them into our little formula. This negative sign is part of the formula, and then our b value is 6. 2 times our a value in this case is 3. We do a little simplifying. 2 times 3 is 6. Negative 6 divided by positive 6 gives me negative 1. So my axis of symmetry is x equals negative 1. So let's go ahead and put my axes in. And it says our axis of symmetry is x equals negative 1. So there's the axis of symmetry. Let's talk about our vertex. Remember, the vertex, the x value of the vertex, is the same as the x value for the axis of symmetry. So I already know the x value for the vertex. Now you might be thinking, well, how do we find the y value then? If I know x, just like when we made all of our tables for vertex form, if I know x, all I have to do is substitute that value in for x and solve for y. So y equals, I'm going to take my equation, 3 times, and I have x squared, 6 times x plus our 2. So again, this is my equation that I started with. If we look up by number 5, all I did was substitute negative 1 in for each x value. Let's do a little computation. Negative 1 squared is 1. 6 times negative 1 is negative 6. And then we just have our 2. 3 times 1 is 3. 3 plus negative 6 is negative 3. And it turns out in this case that our y value actually comes out to be negative 1 as well. So my vertex is at negative 1, negative 1. Now you might be thinking, okay, Miss Guys, we have an axis of symmetry and a vertex, so now do I have to make a table? And the great thing is the answer is no. You don't have to make an entire table. We're just going to find the y-intercept. And then our graph is symmetric. So if I know the y-intercept, I know the point on the other side of the axis of symmetry. It's mirror image. So remember, for the y-intercept, the x value is always 0. So if I go up to my original equation and I put a 0 in for all of my x's, all I'm left with is my c. So my y-intercept's at 0, 2. Now I use the property of my symmetric property and put its mirror image right on the other side of the axis of symmetry. So I know some of you right now are thinking, awesome, no more tables, and you're right, we don't have to use a table for this. The other idea we want to touch on with standard form is the idea of having a minimum or maximum value. So let's go ahead and turn back a page to page 258 in your student journal. And right up at the top, we have maximum and minimum values. A maximum value is when the graph opens down and we have the highest point on the graph. Now the key here is though we don't want the entire vertex, we just want the y value of the vertex. That is considered the maximum point. Because remember, the y value deals with the up and down, the vertical. So if we're talking about the highest point, we want to focus on that y value. Now when our graph opens up, now the vertex is our lowest point, so it's considered a minimum. But again, if we're asked for the minimum, we just want the y value of the vertex. I also want to take this opportunity just to refresh you on how you will know if the graph will open down, which would mean a maximum, or if it opens up, which would mean a minimum. Remember, when your a value, that number in front of the squared term, when it is less than 0, which means it's negative, that causes a reflection, which causes our graph to open down, which would mean a maximum. When your a value, so the number in front of the squared term, when it's positive, our graph does not reflect, so it opens up, and then that would result in a minimum value. So let's go back to page 259, and let's just look at a couple examples dealing with where we have a maximum or minimum value and finding that maximum or minimum value. Now along the way we get to also refresh on how we would find our vertex, because to find the maximum or minimum value we need our vertex. So let's take a look at number 8. Let's start off with the idea though, is it going to open up or is it going to open down? Here's my squared term. The number in front of it is negative. So this graph is going to reflect, which means it's going to open down. If it opens down, that means our vertex is going to be the highest point, which means we will have a maximum value. Now, how do we actually find that maximum value? That's when we use our negative b divided by 2a. The a value again is the number in front of the squared term. The b value is the number in front of the x term. And then we'll go ahead and label c while we're at it. It's just our plain old constant. So let's find our x value of our vertex. We need negative, then our b value is negative 5. So the negative sign in the formula does not take care of that negative sign that is part of our b value. Divided by 2 times a, and a is negative 1/2. If we do a little simplifying, our negative 5 becomes positive 5. Positive 2 times negative 1/2 will be negative. Half of 2 is 1. So the x value at our vertex is negative 5. To find the y value, substitute negative 5 in wherever we see x. So negative 1/2 times negative 5 squared minus 5 times negative 5 plus our 2. We can go ahead and cross out number 11. We're not going to use that one. And let's do some computation. Exponents before we multiply. So the negative 1/2 stays. Negative 5 squared is 25. Negative 5 times negative 5 is positive 25. Now I know half of 25 doesn't work out to be the greatest number in the world, but it doesn't work out to be too bad. It's just negative 12.5. Negative 12.5 plus 25 is 12.5. So our y value is 14.5. And that's okay that we have a fraction for our y value. So our vertex would be negative 5, 14.5. We already talked and said this would be a maximum value. And it's always the y value at the vertex will be the maximum. Let's try one more of these. Let's look at number 9. And we're not going to do 10 or 12 or 13, so if you need some more space, that's okay. Let's first of all start off, is our graph going to open up or down? Our a value, which is the number in front of x squared, is positive, so it's going to open up. If it opens up, that means our vertex is going to be the lowest point on our graph, so we're going to have a minimum value. Let's use our little formula to find the x value at our vertex. A will be 8, B will be 16, C will be negative 2. So let's substitute in. Here's the negative sign that's part of our formula. 16 for B, and then 8 for A. So negative 16 divided by 16. Our x value at the vertex will be negative 1. To find y, we substitute negative 1 in for x into our original equation. We do some computation. We do our exponent first. And we get our y value equals negative 10. We set our graph opened up, so we're going to have a minimum, and it's always the y value at the vertex. It's always the y value at the vertex. Now I do want to look at question 14 just real quick. We're not going to solve it out. I just want to give you some hints as to how you would go about the question. You're given a function. Similar to what we saw when we were working with vertex form. But now instead of having to create a table to answer the question, now we can do things much more quickly. We have the function h equals negative 16t squared plus 250t represents the height, h, in feet of a rocket t seconds after it's launched. The rocket explodes at its highest point. So we want to know, when does the rocket explode and at what height? To answer those questions, you need to find the vertex. The x value that you find will be the when, because it will be the seconds. The y value that you find will be the height. It'll be the maximum point. So finding that vertex, remember, negative b divided by 2a. So what we just worked through in questions 8 and 9. So if you want to know at what height it explodes at its highest point, that's going to be our maximum value. And then when does the rocket explode? That's going to be the x value. X is representing seconds in this case. So just a little hint there of how you might set up some of those questions. You will have some like that in your practice. So if you need a little more help with those, when you get to those in your practice, just let me know. So now at this time, go ahead and grab a progress check. You may use any of these notes that you want on your check.